All right, here we are in 4.5 B. Chapter 4 is linear inequalities, or sorry, systems of equations. 4.5 is linear inequalities. Here's our video B talking about graphing linear inequalities, and we're going to graph another example really of one-line inequality, because then we can kind of use the idea of graphing the one-line inequality to graph a system of inequalities. So let's go down to the next example. And remember again, this is what we're going to do. We're going to start with an inequality. We're going to format it into y equals mx plus b format, so we can pull out the slope and the b and get the y-intercept and graph the y-intercept, graph a point, graph a line, and then determine whether it's an inequality that we use the solid or dashed line with, and then determine which side to shade. All right, so here we go. We're going to have graph the solution set. So here's our instructions. Graph the solution set. So it says graph. All right, we've got a graph. So let's go over here and say, you know what? Here's my line, or my inequality, I guess, is 4x minus 2y greater than 6. We can't really graph that easily. We could get some test points, or we could go with x-intercept and y-intercept, but let's try and put it into y equals mx plus b format, because that's kind of what we know and what we're comfortable with. So I'm going to go 4x minus 2y is greater than 6 and say, you know, I'm going to start with that. I got to put it into y equals mx plus b format. How do I do that? I subtract 4x, and I go over here and I say negative 2y greater than negative 4x plus 6. Now I got to divide by negative 2, and what I have to do is negative 2 divided by negative 2 gives me y, and negative 4 divided by negative 2 is positive 2x. Positive 6 divided by negative 2 is negative 3, and what I have to do with the inequality is flip it, because when you divide by a negative number, you flip the inequality. When you divide by a negative number, flip the inequality. So instead of being a greater than, now it's a less than. So here's our y is greater than 2x minus 3. And what can we do? We can pull out the slope, m equals 2. We can pull out the b equals negative 3. We can pull out the y-intercept and say that the y-intercept happens when x equals 0. And b is right here, negative 3. And now we start with graphing all these points. We can start with the point here, 0, negative 3. 0 in the x direction, 1, 2, 3, negative direction for y, and there's our first point. And our next point comes from our slope. Slope is 2, or 2 over 1, or negative 2 over negative 1, and that's my rise over my run. All right, so if I use this slope, I say my rise is 2, 1, 2, my run is 1. There's my next point. If I use this slope, negative 2 is my rise, 1, 2, and negative 1 is my run. There's my next point as well. And now I've got three points that are collinear, and sure enough, that will make a line. But now I have to determine, do I make a solid line? Do I make a dashed line? This has it does not include an equal sign, so we have to use a dashed line. So we go like this, or something like that. And with a straight edge, it would be a lot easier. So there is my line, or my dashed line, because that's now my kind of dividing line. So now we use a test point to say which side do we shade. We use 0, 0, and we start with our original equation, 4x, or original inequality, 4x minus 2y greater than 6. And I say use test point 0, 0, 0 in the x, 0 in the y, and see if this makes a true statement down here, we shade this side. If it doesn't make a true statement, we shade the other side. So let's go over here. 4 times x, x is 0, so that's 0. Minus 2 times y, y is 0, so 0, because we're using our test point of 0, 0. Greater than 6, question mark. Is 0 greater than 6? 0 greater than 6. Let's see, it is not. So this doesn't make sense to have that in our test point, or to have that in our solution set. So our solution set is the dashed line and this side of the shading. Now, if you just had one area of the shading, you could, I guess, do this. Some people do that. But later on, when we have a system of equations, this lines system over here makes things kind of busy on your graph. So that's why I recommend using the arrows. So I would recommend using these arrows to say that this is my solution set. So there is another example.